Okay, another example for us in Chapter 6, Section 2. This is example 6-10, coming from page 334. Talking about the theme of systolic blood pressure. For medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. Assuming that blood pressure readings are normally distributed, see, there's that assumption that we're always going to be making that it's normally distributed or approximately normally distributed. Sorry, anyhow, back to it. let's let's just go ahead and flash this under here. Let's see. Can you see that there? Yeah. Assuming that blood pressure readings are normally distributed in the mean systolic blood pressure, remember that means average. So if you see average, that means mean. Either way, that's where I get mu is equal to 120. And the standard deviation is, that's sigma, remember, is 8. Find the upper and lower readings, the cut scores, that would qualify people to participate in the study. Okay. All right, so what did I say? Oh, I did say mu is equal to 120, sigma is equal to 8, and what are we looking for? The middle 60%. All right, so step 1 is we will sketch the distribution. All right, let's pause and see how that goes. All right, so yeah, looking at your picture, I can see that's what I got too. All right, here I have the the mean at the center, and I have not yet marked it. That would be 0 if it were the z distribution, or if we're looking at our particular normally distributed data set, the mu, the mean would be 120, so that would be at the middle there. But either way, I've shaded in the middle 60%. And so notice that that makes what? This value here, this side, since it's evenly distributed, is going to be 30%, and this side is going to be 30%. Right? And then, again, since it's symmetrically distributed, not that I'm a perfectionist or anything, that part never touches the x-axis, and it's exactly equal to that side. But anyway, it's just a sketch. Don't worry about it. Don't trip. Okay, so we got what? 20% on either side. So hopefully, let's see, 20, 30, 30, 20. Okay, that adds up to 100, and we're good to go from there. So notice again, the z distribution is perfectly symmetric. So when we are finding these very common z values, we're going to have z over here and z over here, and they're going to be mirror images of one another, about 0. All right, so we'll find the z value on this side and the z value on this side. And the easiest way to do it is, remember, this is not the area that we want to actually find. This is the area we want to find, but we have to find these critical cut scores, the z values. And so over here on this side, we want this area to be exactly 0.20. All right, so we want it to be 20%. Once we find this z number, this negative z value, we'll just write in the exact opposite positive z value over here, because notice that right area would be exactly 0.2. All right, so we'll pause and look those up in our handy dandy Z table, okay? So I'm sure you'll get the exact same thing as me too. Okay, so yes, look at this. We're all looking at the exact same value on the Z table, except me. Oh no, there it is. There, I'm looking at it too. All right, 2005, it seems to be as close as we can get to 2000. 1977, 2033, obviously not. Yeah, 2005, that's as close as we can get. So what is that? That's negative 0.84. All right, sounds good to me. That's what I got too. Thank you for helping. Yeah. That would be negative 0.84 for our z value on the left side, because its left area is exactly 0.2005 technically, but that's close enough to 20%, right? That extra fraction won't kill us, hopefully. All right, so that on the other side is positive 0.84, because this right area would be exactly 20%. And so there we've got the exact middle 60%. So that was step 2. We found the, what are those called? Oh, yeah, at the end of step 2, we should have the z value. Find z given the probability, or the area. We figured out the area, and so then we use the table to convert that area or that probability into the corresponding z value. So what's the next step? Well, we got a little preview of it. My hand wasn't in the way. We're going to use our formula. X equals, what do? We do z times the standard deviation. So that's how many copies of the standard deviation we're going to add on to whatever the average is, right? And here I say we can add or subtract, but the z value will tell us exactly what we're doing. If it is negative, then we will be subtracting. We don't have to do anything to that plus. We'll just have a negative value, so it will take us down automatically. Right, so there's our formula. Oh, shoot, I should have let you guys guess that. I should have paused. All right, well, we'll go ahead and plug in together. So I'll pause here. All right, yeah, so here, that's what I got to. Let's see. So I am, let's see, what did I do? I did negative 0.84 times 0.8, or no, times 8 plus 120 equals, whoops, I wrote that one in the wrong spot, okay? I just did this one, and this one was 113.28. And here in the blank, I just gave you another opportunity to write z times sigma plus mu. And here, z sigma mu. And then we did it again, replacing what? Z with 0.84, sigma here, 8 plus 120. I just want to show you on your calculator, usually if you, well, I mean, it doesn't matter what order you do things in, but if you are using a version of the formula that is more in line with the order of operations. For instance, here we did the multiplication and then the addition. If we had used the books version, which is this, right? Oh no, if we had used the version that I wrote down the other page, which is this, mu plus z times sigma, there we'd maybe have to be a little bit careful about it. And at any rate, anytime we're doing a calculation, it's a good idea to try to do it all at once. And so that will mean these parentheses keys on your calculator here, this and this left and right parenthesis will be your friends. Use them as often as possible. Don't forget to always close off the left parenthesis with a right parenthesis. And so here are X values for systolic blood pressure. The middle 60% should fall between 113.28 and 126.72. All right, that would be the middle 60%. So there we are, finished example 6-10.